At what age did you begin to understand electricity? We are the Resistance. My name is Asim Ghazi and I'm the team lead. This is Jacqueline Granite, our document manager, Gurman Singh, our schedule manager, Brett Gable, our software lead, and Neebus Chaudhary, our hardware lead.
At the beginning of the semester, we asked ourselves this very question and found that the first time electricity was truly explained to us was our sophomore year in college here at UTD. This is ridiculous because we're expecting high school students to declare their major without understanding the basic concepts of electricity. The goal of our project is to bring these concepts to elementary school and middle school age students in a safe environment.
So how do we actually plan on implementing this goal? Well, to start off, we want the actual circuitry of the electro-wires to be hidden from the user. Second, we also be displaying the LEDs, and then we will display the current intensity and direction. Furthermore, we'll be creating a software system that will actually have the analyzing the circuit that the user has built. And last but not least, we'll have providing documentation that will get the users some sample circuits.
The process for our design begins when a user has placed the blocks on the board and presses the simulate button. The Raspberry Pi will then decode from the switch input what elements are placed in the circuit and then simulate that circuit in NewCap. It will grab the current information from that simulation and send that to the Arduino, and the Arduino will then light up the LEDs to display the current accordingly. And the block diagram displays how all our pieces will communicate.
Now that we have all these theoretical ideas, how do we make it come to life? Well, we've decided to implement these acrylic blocks that represent different components. Later, the user will place these blocks on the white spaces in the diagram as well. After all the desired blocks are placed, the board will resemble a complete circuit.
So now, once our product is complete, how do we effectively evaluate our project? Well, we've broken that down into three categories. The first, is our product informative? Does the simulation of the user-created circuit match what we expect from the equivalent physical circuit? The second aspect in that category is, viewed from above, does the board that we create look like a circuit schematic? Because as you might have seen with Mahib's blocks that he's holding there, we actually use the circuit symbols so they get some familiarity with circuit schematics. Now the second category is user engagement, right? We want to make sure that our product is aesthetically pleasing enough to hook the user. And then once the user is hooked, we want to also make sure that they enjoy experimenting with the toy, so that pairing those two categories together builds an effective teaching tool. And then the third and final category is more for ourselves. We ask ourselves a question: did we as a team, at the very end of Senior Design 2, create a product that accomplishes and meets project scope? We are the Resistance. Our project is Build a Circuit, an interactive circuit builder. Thank you for your time. Take questions now.
Any questions?
What does the output look like? Is it just showing the way the circuit is flowing, or is it the current is flowing, or
Absolutely, exactly. So once the blocks are placed, so once the user creates a circuit, for example, they flick the switch, and once that switch is flicked, the LEDs will actually display magnitude, so there'll either be variable brightness or the speed will change, and then also the direction. So it'll show exactly which direction the current flows. And we're of course going to use positive to negative convention.
So what is the objective of your project?
We want to bring electrical concepts to children at a younger age. Because as Jackie had mentioned, a lot of times you're picking electrical engineering as your major and you might not understand the fundamentals of electricity, right? Because present day solutions that kind of match this, a lot of times, for example, snap circuits. You put all the blocks together and the fan turns on. But you don't know how the fan turns on. For the kid, it's just magic. I just put a bunch of puzzle pieces together and the fan turns on. But here, our goal is we actually want to show that current flow is flowing through our circuit schematic. So not only are they understanding current flow, they're actually also understanding a circuit schematic, how it would look, because you're going to actually have resistors and diode symbols.
But have you made it interactive as well, where they can play with it or do something different, interactive?
Yeah, exactly. So the board is set. So we're going to have a 4x4 node board. They'll have variability when it comes to placing the blocks down. So they can build whatever circuit they want. And that's how they are.
So I'm seeing your code here, so that's probably for your microcontroller. How do you map these codes to
how you place the block on the board, what's the
That's
concept?
yeah, absolutely, that's a very good question. So, if you come by our table, we have a demo to kind of show that off. But essentially how we do that is there's going to be 3 switches in between each pair of nodes, right? And based on what the switches read, it'll actually tell me. And there's a reason we didn't put like diode facing which way, like in text, because it's kind of hard. But as you can see, 001 will tell you the diode is facing this way. And then because, I mean, there's symmetry with the encoding, 100 will tell you that the diode is facing that way. And that's why in the demo that we have at our table, it'll actually tell you anode is connected to this node, cathode is connected to this node, because at the end, we're going to take that information, write it to a circuit file, and feed it to NewCap, which is very similar to PSpice. So if you're familiar with PSpice code, you have to name the nodes, and then tell which elements.
So each block will have codes.
Exactly. Exactly.
So as your grid gets bigger, your number of error cases that a kid can get by putting things in incorrectly or shorting things out even with no resistors at all between your power supply. All these error cases, how are they handled?
Sure. So one of the things we wanted to make sure we had was documentation at the very end. To actually tell the user that, okay, well, you can't do this for this such and such reason, or we have some sample circuits for you. Along with that, our goal is to also, a stretch goal would have some voice interaction, but for now, in our goals that we want to for sure accomplish is at least some sort of feedback, like maybe a red LED that lights up when there's something wrong. And they can possibly see that and say, okay, there must be something in the documentation to tell me why this is going wrong.
What is your power source?
It's just an outlet. We have everything.
You have 120 volt, like AC power, or you have like a 6 volt DC battery or something? Or?
No, yeah, it's just plugged into a wall outlet, so the AC,
Okay.
yeah, AC source.
You plan to increase the circuit elements, or
What was
you plan to increase the numbers of circuit elements?
No, well, we have 5 block choices for them now, because we want to ensure that at their young age, they should be able to maybe understand DC circuits. But if we include capacitors and inductors, it becomes a little past our project scope, because then you're dealing with AC circuit elements.
For which age are you talking?
We're talking elementary and middle school, as Jackie had mentioned. Yeah.
Probably there is a security issue if you connect to the power supply. Probably it would be better to have a backup power supply.
Okay.
That's another option we're looking into, having a battery power.
Okay.
Would you say from a product perspective, maybe this would be a better suited for like a teacher that's trying to teach this?
Absolutely, and that's our
Kid
goal.
itself?
Absolutely, that's our goal. That is our goal. It's we're planning to market it to schools.
So we can keep the input from the block and send that decoded value into the Spice software?
Yeah, so-
The decoded and automate that strictly.
Sure. So the code we're writing in is Python, and we're using optical switches. So the blocks, they'll have safe, non-toxic reflective paint at the bottom of them. So when they're placed in, it'll pick up zeros and ones. That information will get written to a text file, and then NewCap will simulate this. Actually, all you got to do is just write nodes. We're going to number these nodes, 1 through 16. Yeah, they're 4 by 4. So. And then
So what do you plan to do the next step? Are you done already?
no, not at all. That's a very good question. Right now we have a little tiny prototype to show that we can decode and encode exactly when you flip circuit elements and put them in all sorts of arrangements. We can output that, okay, those circuit elements are there. We also have the LEDs running. Our goal is to have that put together where on a large scale, you can put these blocks anywhere you want. And when you flick that switch, the LEDs will display current intensity and direction. So we have to kind of piece that together and kind of enlarge it to a larger scale.
All right, one last question?
Explain again, if somebody insists on shorting something out, despite the warnings, what happens if we win?
Absolutely. So at this point in our project scope, we just want to at least have some sort of feedback, maybe a red LED that lights up and tells them, oh, there's something wrong, and then they would go to the documentation. Ideally, if we can complete this in time, we can stretch ourselves a little bit and possibly put some audio or voice feedback saying, hey, you got a short here. Possibly put a resistor in there or something like that.
When do you expect to finish by?
We want to finish by the end of March, so that we have all of April to actually test it on users, and that's where Jackie has taken the lead as a principal investigator. We're working with the IRB to kind of have this tested with students, actual students.
What's the IRB?
The
Institutional Review Board.
Yeah.
So they make sure that your projects that you're testing on people are ethical.
All right, second thing.